and your screen appears like this. So CustomVision AI/projects. So already I have created some projects. Say for example, for this road traffic images object detection for the road traffic. All you need to do is, anyhow, you are going to use a pre-trained model, and you are going to customize that pre-trained model for your own application. Whatever the images you are going to build an application, first of all, you have to upload all the images over here. Already I have uploaded so many traffic images, and you can see already when I keep the mouse cursor over here, because they are already labeled it like a person and the truck, person and truck in this image. And the next image, if you see a person, truck, a person is labeled it because it's a bullock cart. I think it is not being labeled it. So this object is also not labeled. This is looks like an something like a van or SUV. So this is a truck. There is a person. There is a truck, person, truck. This has already been labeled. I'll show you how with this process very easy. But remember, whenever you wanted to create a simple application based on this, the minimum requirement is at least your model requires some minimum amount of images to understand or to generalize your pattern. Whether it's a car or a truck or a person, your model required because to generalize it. So according to this requirement of this Microsoft product, CustomVision AI, minimum you should have at least 15 boxes you should have labeled in each category. Look at this in the left hand side. I have already how many cars I have labeled across. Okay, it's not about the number of images you uploaded. Okay, the requirement is based on the number of boxes you have labeled it. Cars across all the images I have uploaded, you can see in the left hand side corner, 17 boxes I have created for the cars. And for persons, 18 boxes I have formed for the person. And 18 references I have given for the truck. Okay. If you don't have the minimum requirement is 15 in each class. 15 is required. That is the requirement. Otherwise, your train will not work here. So once you have labeled it, directly you can go for the train and you can see the performance analysis, and also you can do the prediction. So already this is being trained. You could see the performance chart and all. Okay, I'll come to this performance chart and how do you can do it for the production environment predictions. How you can do it for the production environment. So let me create one project from the scratch for you. You have to click a new project. So currently this Microsoft has created this platform only for two applications. One is you can build an application for the classification task. Okay, a CNN based classification deep learning model. Another one you can do it for the object detection. You can see the project type is an object detection or a classification project. Okay, again classification, it's a multi-label and you have to specify. So since we are creating this application for the object detection, you have to select object detection, give some project name. Okay. And also it has some customization also, which domain, which type of application you are building, that is you can select it. and I just go with some general create project. Now it is empty, right? Now it is asking me to add images. Okay. So I have created a project title name LA Advanced Object Detection Demo. Add images. Add images. I have, there's a cars folder. It would take too much time to label all the images, but let me initially let me upload a few files. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 images. Let me upload only 10 images. See, it is asking me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Definitely with the 10 images, I may not fulfill the requirement of minimum 15 requirement per object requirement. I may not fulfill it. Anyhow, just for the sake of demonstration, how you have to do I just wanted to show you how the labeling is very user friendly. Done. Okay. So we have done it. Can you see currently all the images I have uploaded, which is part of untagged option, right? They are in untagged. Now you select the first image. The moment you select the first image, and say, for example, you are going to start putting a bounding box, and you are going to give a description for this. Add region tag. Okay, let me give a name for it. Car. Okay, it's added. It's very, the moment you don't need to put a bounding box and all. The moment you bring the cursor, automatically it is highlight a box for you. So this also a car, right? So if it is a new object, you have to type it again, but already you have created a tag for car. You can directly select this car, and in the background also a car, and the remaining is not visible completely, right? Let us some partial information. If you get, you will be confused in your model. Now this is a person. For the first image, I successfully given the. Now for the truck, this is a new object, right? TRUCK. For the first time you are labeling, so truck. This is a person. So the moment you bring the cursor over here, automatically it will pop up whatever the objects you have already labeled. I have to select person. Okay, go to the next picture. Maybe this is it looks like an SU, but let us assume that I'll consider both SU and the normal hatchback as considered as one single canopy as a car. So this is person, and this is also a person. This also a person, and in the background this is a person, and this is a car. The car, this is a person, and this also the car. Truck. That's all. So once you've completed for the 10 images, okay, now can you see automatically those 10 images are shifted to the tagged folder. Earlier it was there in the untagged folder. Now it is came to the tagged folder. Now if you double click and you see all are tagged. Next image, if you see all are tagged, truck, person, car, person. This is car, person, person. So far, how many objects we have tagged? Under car category, 8 numbers. Under person category, we have given 5 references. For truck, we have given very few references. Only 2 truck only we have given the reference. If you try to if you try to click train, I'll show you. There are 2 options: the quick training and the advanced training. With advanced architecture, will take more time. If I click quick training with a smaller architecture, can you see there's an error message? It shows can't train. Your project can't be trained. Just make sure that you have at least 15 images for every tag. Okay, we are not meeting the criteria. So once you create that 15 images per tag, okay, then it will undergo training process. Once it completed the training process, you can see the performance analysis. Okay, so let me go to already the trained project. Let me take this trained project, which meets the requirement, a minimum 15 image requirements. This has already been trained, and I'll go to the performance analysis. So once you complete this training process, this will take, if it is a quick train, it will take hardly less than 2-3 minutes, according to the volume of images. However, this is a very less number of data set. It took me around 2 to 3 minutes. Suppose your application, you have used hundreds and thousands of images. Maybe you have to wait. Even a quick train may take 30 to 40 minutes, according to the size of the data set. Okay, let us understand what is the okay, this validation has been done for the entire image data sets. Whatever the entire image you have tried it. Totally, we have person 18 images, right? 18 car, we have 17, and truck, we have 18. So how to understand the recall score? What is the recall score here? What is the meaning of this recall score? How do we define this recall score? If your input image, there is a frame, in input image, there is a person, how good your object detection algorithm detecting a person as a person is the recall score. Suppose totally you have got 18, okay? Out of 18, only the 15 cases it's correctly detected a person as a person. A few frames it's failed to detect the person, means only 15 cases out of the 18 images predicted, that is the recall score for the person. So nearly it's 90%. So out of every times it meets there is a person object in a frame, okay? At every 10 times it sees the person, 9 cases it's correctly predicted. So this is the interpretation of the recall. Similarly, look at the interpretation of car. Not all the cars are being correctly predicted. Only 75% of the occasions car have been correctly predicted as a car. How many times the truck is correctly predicted as a truck? 100%. So it has not missed any of the truck as a truck. So we can understand the quality of our object detection is a very good recognize the truck compared to the car. So that is the at what rate your model predicts a person as a person, or car as a car, truck as a truck. What about the precision? How do you interpret precision? Is there any other object like a car or a truck is being wrongly predicted as a person? It is none, isn't it? Because look at the precision is 100%. Feel free to ask me, stop me, and you can, if you're not following the definition of precision or recall, don't hesitate, even though it is it's part of your basic concept. Even if you don't remember, don't hesitate to ask me. Okay, if you don't understand the definition. If any other object like a car or truck is wrongly being detected as a person, there is no case. There is a no. Nowhere our model is highlighting an object. There is a car and it does not say this is a person. There is not even a single case. That is why it's 100% precision. And look at the precision for a car. Again, it's 100%. Okay. Not even a single place a person is wrongly identified as a car, or even a truck. A truck is wrongly identified as a car, not even a single case. We have not even a single case, 100%. But for the truck, precision is not 100%, it's only 83%. That means might be there is a car, your model is detecting truck. Some other object is wrongly detected as a truck, it will pull down the precision. Can you able to differentiate recall and precision? A particular object correctly predicted as the same object, recall talks about it. If any other object which is wrongly predicted as that particular class, your precision talks about it. Any question on precision and recall? These two columns, if you have any query, feel free to ask. Then I'll come to, we have two more metric. One is the average precision. With this average precision, we are calculating for each class, and then overall average is being reported as a mean average precision, MAP score. So before I'll come to this AP and MAP, do you have any question on precision and recall? Are you clear about this?
Clear.
Okay. Yeah, fine. Great. Okay, now how these scores are being computed, average precision score. This is something new for you. Generally, we have not done this in our traditional classification algorithm at all. And however, we are familiar with the ROC graph, isn't it? We are familiar with region of convergence, AUC score, ROC graph, AUC score. How this AUC score is being calculated? AUC score is being calculated from, okay, y-axis, true positive rate, x-axis is false positive rate. That means your alpha versus your true positive rate, which is 1 minus beta. True positive rate is the sensitivity of the model, isn't it? So 1 minus beta is the sensitivity of the model. Either you can call this y-axis as the sensitivity or true positive rate, or you can call it as a 1 minus beta. And x-axis is alpha error. Okay, y-axis is not an alpha error. Okay, the balance of the y-axis is not a beta error, the balance of the beta error. What is the balance of the beta error? Sensitivity is the balance. So 1 minus beta you can call, or a sensitivity you can call. How this AUC score is being calculated? So internally your model will predict the class probability, right? So it uses a multiple thresholds at, let us say, at 0.5 thresholds, above 0.5 belongs to one class and below 0.5 belongs to another class. If it uses a 0.5 threshold, what is the, it will build a confusion matrix. For that confusion matrix, it will plot a point. And it will change the threshold, like 0.75 is a threshold. What is the sensitivity and alpha? And with the different thresholds like 0.6. So it will work out for all possible thresholds like 0.01. Actually, your built-in function in Python will work for all possible thresholds. And finally, so we are all familiar with AUC score based on sensitivity versus your or TPR versus FPR graph. Something similar to this, we can also plot. Okay, we can calculate the area under curve for precision versus a recall graph. So this is not a usual practice in a classification task. And again, there is nothing wrong Since it is not a usual practice, nobody is going to stop you do this calculation even for your classification task. Even some of my classification tasks, I have done this precision recall graph. In the same manner, you can plot precision versus recall. We have Python functionalities are available to do this precision versus recall graph, which is going to work on multiple thresholds. It will work out for all possible different thresholds. It will connect all the points, and it's going to calculate the area under the curve. So this is whatever the score you have obtained for at one particular cutoff, which is 0.5. The default is a 0.5 because the 0.5 is the safest margin, isn't it? Whatever the score you are seeing, it's for the standard threshold, which is 0.5. But if I modify the threshold probability thresholds for different possible values, what is the average? I'm calculating this only for the average precision. What is the average precision I obtain this? The area under the precision recall graph, that metric is called as the average precision quantity. Analogically, this is something similar to area under the curve for TPR versus FPR graph. This value is being calculated from precision versus recall graph. That area under the curve. That area under the curve, they are calling as average precision. Average. Similarly, you do the same thing for at what rate your model is correctly predicting for the car. Precision recall graph for this class, you obtain this, and similarly for the third class, plot the precision recall graph and we obtain this. And overall average of this 90 plus 95 plus 100 all divided by 3, that is this final MAP score, mean average precision. So this is the individual object wise, and this is the overall. So the individual score also important. Okay. So basically, with your overall score to have a very good, because it will be high. Suppose if there is a high level of skewness, your overall score will mislead, right? So your individual score is also important. At the same time, when you tune the architecture, make sure that your individual scores are important. If the individual scores to be very good, make sure that your precision and recall should be a very compromising score. Sometimes your object having a 100% precision, but on the recall side there is a downfall, 90%. Again, a precision said 100%, and the recall is very poor for the car. That means your car is not being, some of the car is not detecting. The reason is it's a complaint about the architecture. Some of the cases I have not labeled all the cars. That is the reason actually. I have not, in every picture, I have not labeled all the cars. Some objects, some of the cars are very far away locations. Those cars are not being detected. That is the problem. I will show you how you can understand how I realized it. What is the reason behind this 75%? When I investigated, I came to know that it's not the fault of the algorithm. It's the fault of my labeling process. So to judge that, you can come to this predictions. After analyzing the performance, now you come to the predictions. So some of the images I just tried the predictions. Okay, this is the input image when I had given. It's predicting this as a truck with 96% probability. It's predicting this as a person with nearly 84% probability. You can also control the threshold, probability percentage threshold value you can control. If you put threshold value is 95, it's detecting only truck, because the person is not being detected, because the person was detected with slightly lower probability score, 84%. So another the predictions, instead of doing for the already done one, let me go for a quick test. Okay, I have to upload a file, browse local file, some other file. See this file and all, it's the model will do a good job. You can look at this, very less number of objects. If I try now, it's predicting. Okay, lively predicting for the text case. This is a production environment. Truck is predicted with 80%, 81% probability. Car is predicted with 83% probability. Some other production image, let me pass with where you have a small sized objects. Maybe.
Sir, can you please repeat this? How to start testing production images from where?
Yeah, I'll show you. See, say for example, this case, a person is detected. This also person is detected. There is a third person is detected. All three persons are detected successfully. Okay, you could see there are three person, and there is a truck, and this bullock cart also is detecting as a truck. Okay, this is a false positive, isn't it? And why the recall score of the car has gone down? So 3% and 2 track it is showing these two. Okay, once you have done this performance, you come for this predictions. Okay, predictions. You have to click this quick test. Okay, training images. Here, when you do the training process, this is the training process. When you do the training, it will ask you whether you wanted to do the quick test with the smaller architecture or the bigger architecture. That part is different. After analyzing the performance, when you come to the predictions, here you have to click quick test. Now it will ask you to upload any live, any new case. So for this image, this is being predicted as a car, person. Originally, we have labeled this as a car, right? This person and this is person. Few cars. So there is some overlapping between car and truck. But for the person, it's perfect. So in this frame, it is detecting, there are totally 3 cars it is detecting, even this far away car. 1, 2. See, maybe in the original image, suppose I have labeled this car. Okay, look at this, the background. In the original image, I have labeled this background also car, but this model has failed to detect this car, right? But in the reference, the ground truth, this is being a reference labeled as a car, or even this background also I have labeled as a car. Means originally it is a car, but my model is not predicting this as a car. It will pull down your recall score. Suppose if your truck is wrongly predicted as a car, the precision of the car will go down. When the recall of the car will go down, in the original image, this background car is being originally labeled, but my model fails to detect this as a car. Your recall of the car will go down. So do you have any question on these tools? CustomVision AI tool. You can try to build some interesting application based on this. All you require is what, even though it is free, okay, it will actually, they will charge based on your usage. So how many minutes or how many hours you use it. Pay as you go option is there.